first thing we're going to talk about is average rate of change. You should have hopefully heard of average rate of change already. But average rate of change is just a fancy name for what?
Slope.
Slope, exactly. Perfect. Very good. Average rate of change is just fancy words for slope. And we know what slope is, right? Rise over run, y2 minus y1 over x2 minus x1, right? Change in y over change in x, delta y over delta x. However you want to write it, however you want to say it, right? It's how much our function goes up compared to how far it goes over in some interval, right? Slope. So if I ask you to find the average rate of change of, let's say, f of x equals x cubed minus x on the interval from -1 to 3, that should be pretty straightforward. Shouldn't it? Yes. I'll answer my own question if nobody else will. Yes, it should be pretty straightforward. We know that our x2 value should be 3 and our x1 value should be -1. We do need to figure out our y2 and our y1, so we'll figure out what f of -1 is. What's f of -1?
Zero.
Should be -1 minus -1, which should be 0, I think. Yeah. And then what about f of 3? Should be what?
24.
24, good. So we got 24 minus 0 over 3 minus -1. So 24 over 4. For a slope of 6, an average rate of change of 6. So when we think about average rate of change, we know that's slope. It means over the course of those 4 units, our function goes up 24 units. Now, that doesn't tell us much about what happens on that interval between -1 and 3, other than between -1 and 3, it changes by 24 total units. And that's all it tells us. We're going to work with this idea of slope and average rate of change, though, and learn a lot more about it as we move forward today. So what we're first going to do is we're going to write a new generic slope formula. Using any generic function, we'll call this function f of x. And we're going to go from some point x, f of x, to x plus h, f of x plus h. So if I'm going from x to x plus h, what should this distance be?
H.
Yep, should just be h. Okay, so we're going to want to note that as we go through here, the difference between x plus h and x is just h. And our slope formula then becomes what? What's y2?
F of x plus h.
F of x plus h. And what is our y1? Should be f of x. And we already said x plus h minus x is just h, right? That's the difference between them. So we end up with this formula, f of x plus h minus f of x all over h. This should look familiar to you. Does that look familiar to anybody? Does that look familiar? Anybody seen this before? Good. This is called the difference quotient. It should look familiar. If it doesn't, that's okay, because I've just shown you how we get it, and now I'm going to show you why it's important and how we use it. But this is called the difference quotient. And the difference quotient can be used to find the slope between any 2 points on a function. And we will refer to the line between any 2 points on it. This blue line here is called a secant line. A secant line is just a line that cuts through 2 points of a function. And so this is the secant line to this function. Everybody good with the terminology there? Difference quotient, secant line, and how we derived this difference quotient from the slope formula for a generic function f of x. Yeah, okay. So what we're going to do now is we're going to take a function. Let's start with this one, x cubed plus 2x minus 1, and see if we can write a formula using the difference quotient that will allow us to find the slope of the secant line through any 2 points of the graph. So we're going to use our generic difference quotient slope formula and use this function as f of x. So what should it look like to begin with? Should be f of x plus h. What is f of x plus h?
Like x plus h cubed plus 2x plus 2h, and then minus 1.
2x plus 2h, or 2 times x plus h. I'll distribute that in a minute. And then minus 1. Right? That's this piece right here. This is our f of x plus h piece. Then we're going to subtract f of x. That's f of x. And put it all over h. Good or no?
Makes sense.
Good.
All right. You may be a little like, it's okay if you're at this point a little bit confused about like why we're doing this. It's going to make sense when we graph it and kind of look at it and move forward through the day. But everybody understands that this is f of x plus h minus f of x all over h.
Mm-hmm.
All right, cool. So let's expand out x plus h cubed using the binomial theorem, Pascal's triangle, all that fun stuff. It should come out to be x cubed plus 3x squared h plus 3xh squared plus h cubed, and then the plus 2x plus the 2h, and then the minus 1. And then the minus sign gets distributed to all of those. Oh, that was already, that should have been a plus right there. All over h. Isn't that a nice formula to represent the slope of the secant line? Super simple, super convenient. What was that? Somebody said something.
Oh, I just said wonderful.
Yes, it's wonderful. I agree. It would be even more wonderful is if we could cancel some stuff out, like an x cubed and a minus x cubed, and a plus 2x and a minus 2x and a minus 1 and a plus 1. Everybody good with canceling all those out? So that leaves me with that 3x squared h plus 3xh squared plus h cubed plus 2h all over h. And what do we notice about all the terms that are left?
They all had h in them.
They've all got an h in them, and that's going to happen anytime we go through and do this. Anytime we use a polynomial here, all the stuff that didn't have an h in it is going to end up canceling out. So since these all have an h in them, we could divide each term by term by the h and simplify it just a little bit more to get 3x squared plus 3xh plus h squared plus 2. Everybody good or no?
Good.
How did you get the f of x plus h at the top left?
Okay, so this is f of x. So let's think about it this way. This is f of x, right? What's f of 1? F of 1 is 1 cubed plus 2 times 1 minus 1, right? True? What about f of a? F of a would be a cubed plus 2a minus 1. Well, we're interested in what is f of x plus h, so that should be everywhere you see an x, replace it with x plus h. So x plus h cubed plus 2 times x plus h minus 1. Does that make more sense?
Yeah, I got it now.
Cool. All right, so this formula that we got, this represents the slope of the secant line to f of x. Let's first off pick a couple of x values. Anybody got, let's pick a simple one like x equals -1 and how about x equals 2. Let's see if we can find the slope of the line that goes through the points x equals 1 and x equals 2 on that graph. So first, let's take a look on Desmos at that first graph. Our first graph was x cubed, what was it, plus 2x minus 1 or something like that? Is that right? Is that our graph?
Yeah.
Okay. And so we're interested now in the line, the slope of the line that goes through -1 and 2. So I'm going to shrink this down a little bit so I can see where it hits at 2. But between -1 and 2. And so we should be able to use this formula that we've written to figure out that slope. Our formula, 3x squared plus 3xh plus h squared, what was it, plus 2? Yeah, plus 2. All we have to do is plug in our values. So if we're going from x equals -1 to x equals 2, we're going to use x equals -1, and we're going to use h is equal to what?
3.
3, right? Because that's the difference between -1 and 2. So we should do 3 times -1 squared plus 3 times -1 times 3 plus 3 squared plus 2. And that ends up giving us 3 minus 9 plus 9 plus 2, or a slope of what?
5.
5. And if we look back over here at our graph on Desmos, what do you think? From -1 to 2, it's pretty steep, right? That could be a slope of 5. Is there a way we could be sure that we're right?
Like plug in numbers and actually calculate it.
Yeah, we could plug in the numbers and actually calculate it. Or we could write the equation of the line that goes through x equals -1. And let's see, what's the y, or what's f of -1? Should be x cubed, right? So -1. And it was plus 2x, so that's minus 2. And it was minus 1, so that'd be minus 4. So if it has a slope of 5 and it goes through the point -1, -4, the equation in point slope form should be y plus 4 equals 5 times x plus 1. Do you guys agree with that? And we'll see that they intersect at 211 and they intersect at -1, -4. And that line sure does have a slope of 5. You guys agree or no?
Yes.
Cool. What if instead of wanting to go from -1 to 2, I just wanted to go from -1 to, let's say, 0? Could I still use this same formula? 3x squared plus, what is it, 3xh plus h squared plus 2? Should be able to use the same formula. Supposing I want to go from x equals -1 to x equals 0, what would my h value be?
1.
1. And so we still use -1, so 3 times -1 squared plus 3 times -1 times +1 plus 1 plus 2. And what would we get for our slope? We have 3 minus 3 plus 3, a slope of 3. And so this would be y plus, if we were going from -1, the point was -1, -4, right? 5 plus 4 equals 3 times x plus 1. And we should be able to have that equation right here, y plus 4 equals 3 times x plus 1. And if we zoom in a little bit, we'll see that that touches my graph at -1 and it touches my graph at 0. We've got the right slope. Should work for any set of two numbers that I choose to use. Does that make sense?
Yep.
Wait, could you repeat the y plus 4 equals 3x plus 1 step?
Yeah, so we had a slope of 3, and we knew that the point -1, -4 was the point on our function at x equals -1. So I just used point slope form, y minus y1, so y minus -4 equals 3, the slope, times x minus x1, x minus -1.
Okay, thank you.
You're welcome. Does that make sense?
So when you're finding the point, you plug in the x value into the original function equation?
Correct. That's correct. All right. I'd like you guys to see if you can get this one set up, and then we'll try to work through it together. So see if you can get this one set up into the difference quotient form. All right, sorry about that. It was a little longer than I meant to give you for a minute. My son was needing my help with something for a minute. So how'd you guys set this up? Hopefully 1 over what?
X plus h squared.
X plus h squared minus 1 over x squared all over h. Yeah? Everybody good with that?
Yes.
How do we simplify a complex fraction? Which is what this is, fraction within a fraction.
Common denominator for the top first, right?
Yep, exactly. So that'll be x squared and x squared here. And over here, it'll be x plus h squared and x plus h squared. So we'll rewrite this as x squared minus x plus h squared over x squared times x plus h squared. Now that's all over h, and this is h over 1 in the denominator, right? I could multiply, since it's a fraction divided by a fraction, I could multiply by the reciprocal, and where's that h going to end up?
In the denominator.
in the denominator, right? So we have x squared minus x plus h squared over x squared, x plus h squared, h. So far good?
Yeah.
All right. Let's take the x plus h squared and expand that out. And what about the x squared minus the x squared? That should do what?
Cancel.
Cancel. And then we distribute the minus to everything that's left. So negative 2xh plus h squared over x squared h times x plus h squared. And what can we divide everything in the numerator and the denominator by?
H.
H. So we got negative 2x plus h over x squared times x plus h squared. And this is the formula that will give you the slope of the secant line between any 2 points for the graph of 1 over x squared.
Wait, isn't it minus h squared?
Oh, yeah, it is. Did I swear I said to distribute that minus sign, didn't I? And then I didn't do it myself. Minus. Perfect. Now it looks good. Thank you. Any questions or issues with that? All right, so here's what I now want to ask you. What do you think would happen if we take the interval for h and shrink it all the way down to 0? What's going to happen to our average rate of change in our secant line?
Won't it also be 0? Like the line would be nothing, basically?
So the interval would be 0, right? Which would mean now we can't exactly get it all the way down to 0, but as those 2 points on the graph, and we'll look at the one we had up here previously, as these 2 points, let's say we change this to become, bring this point at x equals 0 to get closer to x equals -1. What's going to happen to that line? It's going to get very, very close to the value of my function, right? I mean, the closer I get here, if I had a tangent line to this point, let's say, it's going to look very similar to that function. And if I zoom in even more, the tangent line, not the tangent line, but the secant line through 2 points, like this point and this point, is going to look almost exactly the same as this function is. Do you guys agree?
Mr. Bachelor, I don't think you're sharing the screen.
Oops. I'm glad I rambled on about that. One second, let me pull that up. Okay, sorry. Can you guys see it now?
Yeah.
Okay. So suppose we had, let's say we had a secant line that went through the point, which we had a minute ago, through the point -1 and through 0. It would look similar to this function, but not exactly the same. Would you guys agree with that?
Yeah.
Okay, so then what if we made the tangent line just be from, I keep saying tangent line, but the secant line just between -0.5 and 0. So like if I drew the line connecting this point to this point, Would it be even more similar to the function?
Yeah.
And if I made it even smaller, let's say from negative 0.2 up here to 0, all of a sudden this line that goes through this point and this point is going to begin to look very much like our function. Would you guys agree?
Yeah.
And the smaller the interval that I make, let's say I'm going towards 0, eventually, if I make it towards just right at 0 for that interval, instead of the line touching the graph in 2 different places, it's only going to touch the graph in one single place. And what do we call a line that touches a graph in just one single place?
A tangent?
Right, this is called a tangent line. So it's going to turn our secant line into a tangent line. But we have a problem with this, is that if h is 0 and we're looking at f of x plus h minus f of x over h, what's the problem we have if h is 0?
It's indeterminate.
Right, this is 0 in the numerator, f of x minus f of x, over 0 in the denominator, just an h. So how can we deal with something that is 0 over 0?
Can you factor?
Well, potentially, depending on the equations that we have in here. But right now, we're just looking at the generic version, right? How do we deal with, or what is a form in which we could have something as 0 over 0, but still be able to deal with it? We'd have to throw in a limit in front of it, and then we can deal with that. Because now, is h going to be 0?
No, just really close.
No, just really close, exactly. So we're going to be looking at what happens to this function, our difference quotient, what happens to the slope as the interval approaches 0. And that should tell us what the slope of the tangent line should be rather than the slope of the secant line. You guys see that or no?
Wait, so why is it a tangent line and not a secant line anymore?
Well, because we're making the interval approach 0. So we're making h, which is the distance from our first x to our second x, get very, very close to 0. And so we're looking at what happens right before that interval basically disappears and we're just sitting at a single point.
So the line like almost like becomes the same.
Basically. Well, at that one point, at that zoomed in one point, yes, it's exactly the same. And the tangent line, as we go further away from that point, it differs from it. But at that one exact point, it's telling us exactly what it looks like.
Okay.
Does that help?
Yeah.
Cool. All right. So, in order to evaluate this, we'll have to use some of our tricks depending on what functions we're looking at. So we're going to give this a try using this formula to find the slope of the tangent line. And this formula right here is what we call in calculus the derivative. And I'm sure you've heard the term derivative before. A derivative is the slope of the tangent line, and it is this limit of the difference quotient as h approaches 0. Okay? So I would like you guys to see if you can use the difference quotient, set this up, and simplify it down some. So give that a shot for a minute or two here. Using the limit as h approaches 0 of f of x plus h minus f of x over h.
It's definitely this one. The very last one. And do my home is this thing.
All right, did you guys get this one set up like that? Okay. And then we should expand out this x plus h and distribute the minus sign. Everybody agree with that step too?
Yes.
Okay, the x squareds should cancel and the x's should cancel. And I should be able to divide everything by h, giving me 2x plus h plus 1. And as h approaches 0, what is 2x plus h plus 1 equal?
Just 2x plus 1.
Just 2x plus 1. And this right here is the derivative of x squared plus x. It represents the slope of the tangent line to that function. And if we want to figure out what is the equation of the tangent line at, and I wrote x equals 3, but I want to pick a different value because when I did that one last period, it doesn't, it's hard to see so well. So let's say at x equals, how about x equals 1? Let's change it to that. That should be better. So what we're going to do is we're going to take 2x plus 1, and this vertical bar here means I'm evaluating it at x equals 1. And what do I get if I evaluate it at x equals 1? 3. So this is the slope. And if I want to figure out the equation of the line, I need to figure out what f of 1 is, which is 1 squared plus 1, or 2. So we have the point 1 comma 2, which should give us y minus 2 equals 3 times x minus 1 as the equation of our tangent line to x squared plus x at x equals 1. Does that make sense so far? So let's look at x squared plus x. And we have y minus 2 equals 3 times x minus 1. And hopefully you can see that my linear black function here is touching the purple parabola at just the 1 point right here at the point 1 comma 2, and then bouncing back off and staying on the right hand side of it. Everybody see that?
Yes.
Okay. Now let's zoom in on that point at x equals 1. We'll note that the closer in we get, the more that our tangent line begins to just resemble the function itself. You guys see that, you know, zoomed in where this is half a unit from here to here, that tangent line is very, very similar to the function. And if I keep going, eventually they're just going to pretty much overlap each other. And this tangent line is a good representation of the function on a very small interval. Everybody see that?
Yep.
All right, cool. Let's go back and do another one. Anybody have any issues so far? No? All right, I want you guys to see if you can get this one started. Try and simplify out your limit and your difference quotient on your own and see what you get. And I'll give you guys a couple minutes to do that, and then we'll talk about it. So we have the limit as h approaches 0 of 1 over x plus h minus 1 over x all over h. Everybody start like that?
Yes.
Okay. And then you got a common denominator for the numerator. So x over x times x plus h minus x plus h over x times x plus h all over h. And then the x minus the x canceled out, so we were just left with the limit as h approaches 0 of negative h over x times x plus h. And what happens to this h in the denominator? It just gets thrown into the other denominator. Cancel the h's. And evaluate the limit as h approaches 0, and what do you get? Negative 1 over
X squared.
x squared. Good. And that's the derivative of 1 over x. Anybody have an issue with that? So we want to know, when does that equal negative 1/4? So cross multiply, cancel out the x, or cancel out the negatives, and you get x squared equals 4, or x is positive or negative 2. So that's the answer to the question that was asked of us. When does this function have a slope of negative 1/4? If we wanted to check our work, we could graph the line that goes through x equals 2 and x equals negative 2 and see if they are tangents. So what's f of 2? It's just 1 over x, right? So it should be a half. And f of negative 2 should be negative a half. So y minus a half equals negative 1/4 times x minus 2. And y plus a half equals negative 1/4 times x plus 2 should be our two equations. Everybody agree with those? There's 1 over x. Y minus a half equals negative 1/4 times x minus 2. And y minus a half equals negative 1/4 times x plus 2. Oops, no. That should be plus a half. We had plus a half written, but. And we see that at negative 2, we have the tangent line, and at 2, we have the tangent line. And they both have a slope of negative 1/4. Everybody good with that or no? Y'all are awfully quiet now.
It makes sense.
All right. Well, let's move forward then. So in this one, we're going to look for what's called a normal line. A normal line is a line that is perpendicular to the tangent line at the point. So in order to find the equation of a normal line, we're going to need to find the slope of the tangent line first, and then we'll use what we learned a long time ago in like pre-algebra about, the opposite reciprocal to find the slope of the normal line. So if we want to write the equation of the normal line, the first thing we have to do is find the slope of the tangent line, which will be a limit as h approaches 0 of x plus h squared plus 1 over x plus h minus x squared plus 1 over x all over h. Everybody good with that setup to begin with? And we can expand out and distribute the negative sign. And what will cancel out? That's right, the x squared and the negative x squared. Everybody sure they're doing okay with this? Because there's a lot of silence out there, whereas usually I'm getting some responses.
It's really long and it's really hard to write out, so I think we're just preoccupied with writing it down.
Ah, okay. If I need to slow down, just let me know. I mean, this is the last class of the day. We can go as long as we want. Okay, so we might note that getting a common denominator between all 4 pieces of this is kind of irritating. But because this is a limit, if I really wanted to, I could separate it out into 2 separate limits using addition. Like this. So keep the fractions together and keep stuff that's not fractions together. And what will that give me here? That will give me a limit as h approaches 0, if I cancel the h's there, 2x plus h. And then on this side, plus, what is this limit right here? We just did this one a minute ago. Should be negative 1 over x squared. Or didn't we just do that on the previous page here? Limit as h approaches 0 of 1 over x plus h minus 1 over x over h equals negative 1 over x squared.
Wait, on that page, how did you get, or the last one?
This one?
Yeah. I'm kind of confused, but so how did you get from negative 1 over x times x plus h is equal to negative 1 over x squared?
Oh, this is the limit as h approaches 0. So as h approaches 0, yeah, negative 1 is still negative 1. X and x are still x and x, and h is gone.
Got it. All right, cool.
Yep. And so here, now that we've replaced this whole limit that we did previously with negative 1 over x squared, we can do the limit as h approaches 0 of 2x plus h, which just gives us the 2x minus 1 over x squared. Everybody good with that or no?
Good.
Yeah.
Cool. All right. Then this is the formula that tells us the slope of the tangent line. We're interested in at x equals 1. We're also going to need to find f of 1. So what's f of 1? It should be 2, right? And then on the next page, let's evaluate our derivative, 2x minus 1 over x squared at x equals 1. And we're going to be looking at the point 1, 2. What does this come out to be?
1.
1, and that's our slope of the tangent line. But we were asked for the normal line. So if the slope of the tangent line is 1 and the normal line is perpendicular, the slope of the normal line should be
Negative 1.
negative 1. Good. So this equation should be y minus 2 equals negative 1 times x minus 1. And we can look at this on Desmos. Our original function was what? X squared minus 1 over x, I think. All right, or plus 1 over x?
Yeah.
Plus 1 over x. And we had y minus 2 equals negative 1 times x minus 1. So that's the normal line. And I could graph also the tangent line, and we could see there's the tangent line right at that 1.12, and the normal line there is perpendicular to it. Everybody see all that?
Mm-hmm.
Any questions or issues on that?
Where did you get the -1 and -2 from again?
the minus 2 and the minus 1 in here
Yeah.
in the equations. So we went through and we said that f of 1 is equal to 2. So that means that we're dealing with the point 1 comma 2 we know is on our graph. And so point slope form, y minus y1 equals n times x minus x1. Is that good or no?
To find f of 1, did you just plug in 1 to the 2x minus 1 over x squared?
No, to find f of 1, we have to plug it into f of x, right? F of 1 is 1 squared plus 1 over 1.
Oh, okay.
Yep. Yeah, and that's something that a lot of people start mixing up as we go through and do a lot of this stuff with derivatives. Is when they're trying to find the point, they always forget, do they need to plug it into the original equation or do they need to plug it into their derivative equation? And to find the point, you plug it into the original equation. You plug that 1 into the original equation. To find the slope, you plug the 1 into your derivative because your function just tells you the points. Your derivative tells you the slope. Does that help? Everybody okay there? Everybody good? All right, we're going to do one more. This will be the last one we do today. So we'll work through this one all the way together. The limit as h approaches 0 of root x plus h minus root x all over h. How am I going to turn this into something that is not indeterminate?
Could you square the whole thing? Would that do anything?
Squaring it is not going to. I mean, it does a couple of things. One is it changes the nature of this function, so it'll give us the wrong answer. But also, it doesn't clear out the radicals or do anything. But you're sort of on the right track. We do need to multiply it by something to both the top and the bottom. Anybody?
Conjugate?
Yeah, we're going to multiply by the conjugate. So oftentimes, if you have a radical minus another radical or a radical plus another radical, you can get rid of all those radicals by multiplying by the conjugate. So that's what we want to try to do. In the numerator, root x plus h times root x plus h should just be x plus h. And root x plus h times root x should cancel with root x plus h times negative root x. And all we'll have left is minus root x times root x or minus x. And we've still got the h times the root x plus h plus root x in the denominator. Everybody good with that or no?
Makes sense.
All right. So we'll simplify the numerator to just an h. The bottom stays the same. The h's will cancel. And we've got the limit as h approaches 0 of 1 over root x plus h plus root x. And what can I do with that then? As h goes to 0, that's just 1 over root x plus root x, which is 1 over 2 root x. Everybody good with that?
How'd you do that last step again?
So I plugged in 0 for h, which gives me just 1 over root x plus root x. And root x plus root x is 2 root x's. Right? Good or no?
Oh, yeah, I got it.
Okay. Cool. So we've got our derivative. We want the tangent line and the normal line. So the derivative should be able to give us the slope and we're doing this at 4. So 1 over 2 root x evaluated at x equals 4 should be the slope of our tangent line, which is 1/4. And so what should the slope of the normal line be?
-4.
And then we also need to find what is f of 4. That's just the square root of 4, which is 2. So we're dealing with the point 4, comma 2. So our tangent line should be y minus 2 equals 1/4 of x minus 4. And our normal line should be y minus 2 equals -4 times x minus 4. Everybody good there? So root x and y minus 2 equals 1/4 of x minus 4. There's our tangent line. Everybody should be able to see, hopefully, that's the tangent line at x equals 4. And right below, we'll do the normal line. There's your normal line perpendicular to it there. And I know I'm leaving all of these in point slope form, and probably your whole life teachers have told you don't do point slope form, leave it in slope intercept form, convert it to slope intercept form. Well, not anymore. Point slope form is just as good. In fact, oftentimes it's much more convenient. If you want to convert it to slope intercept, go ahead, but there's no reason specifically to do so. Any questions on anything we've done today? That's going to be it. Everybody feels okay about all of that? It's a lot of stuff. And starting to get a little more complicated, I think. The limits themselves are pretty easy, but conceptually it's getting a little bit more complicated. No questions?